Hello children, welcome to aimsindia's online classes. In today's video, from math subject, equations and inequations topic we are going to discuss. So here children, let's start with properties of inequalities. Properties of inequalities. So for inequalities, we can apply some properties children. So any expression having the inequality sign like less than, greater than, less than or equal to, greater than or equal to will be termed as an inequation or inequality. For that, some properties are applicable. If A is greater than B, B greater than C, then A will be greater than C. Means when we are comparing three terms, suppose first two terms are 3 and 5. So 3 greater than, first two terms are, let it be 7 and 5. First two terms. First term is 7, second term is 5. Now 7 greater than 5. 7 is greater than 5. And third term is, suppose it is 3. So in the beginning we have compared 1 and 2 terms, 7 greater than 5. Now we are comparing second and third term and we are telling 5 is greater than 3. So then we can establish a relation between first and third term. When we know the relation between first and second term, second and third term, as second term is common, we can establish a relation between first and third term as 1 is greater than 2, 2 is greater than 3. In this case, always first term will be greater than third term. So the same property only, symbolically they have taken like this. If A is greater than B, B is greater than C, A will be always greater than C. Next, second property. So adding the same number to each side of inequality does not change the inequality. Suppose if 7 is greater than 5, if we add the same number on both sides of the inequality, like 7 plus 2 greater than 5 plus 2, 7 plus 2, 9 greater than 5 plus 2, 7, which is true. Means adding the same number on both sides of inequality does not changes the relation. So if A is greater than B, A plus M greater than B plus M. Or if A is less than B, we can write it as A plus M less than B plus M. So the relation may be greater than or less than, but same number can be added on both sides, but still the inequality does not changes. In the same way, subtracting the same number from each side of inequality also does not changes the inequality. Is 7 greater than 5? If we subtract 2 from 7, if we subtract 2 from 5, 7 minus 2, 5, greater than 5 minus 2, 3, which is true. Means when an inequality is given, same number we can subtract on both sides, still the inequality will be the same. There will be no change in inequality. It may be greater than, it may be less than. So in the same way children, so multiplying each side of inequality by a positive number or by a non-zero positive number, because while multiplying with 0, total value will become 0. So that's why we can consider all the positive numbers. Anyway, 0 is not positive. So that's why they have mentioned only positive number. So multiplying the inequality by a positive number does not change the inequality. Same 7 and 5 relation we have. 7 greater than 5. 7 into 2 greater than 5 into 2. 7 2 times 14 greater than 5 2 times 10. So the relation does not changes. If A is greater than B, AM will be greater than always BM. With same number we can multiply, but still the relation does not changes. But the condition is M should be greater than 0. The value with which we are doing multiplication, it should be a positive number. Not negative, not 0. It should be compulsorily a positive number. If the relation is less than, after multiplication also it will be less than. Next. Suppose if we multiply the each side of inequality by a negative number, then the inequality will be reversed. If A is greater than B, if 7 is greater than 5, if you multiply with minus 2, if you multiply with minus 2 on both sides, 7 into minus 2 minus 14, 5 into minus 2 minus 10. In negative numbers, the numeral whose magnitude is more, it will be having less value. So minus 14 is less than minus 10. So in the beginning inequality, greater than sign is there. While multiplying with the negative number, it became less than. Means whenever we multiply the inequality on both sides by a negative number, it reverses the inequality. If A is greater than B and M is less than 0, which means M is negative, so then AM will be less than BM. Inequality changes. If A less than B and M less than 0, then AM will be greater than BM. Inequality changes. Next one. So dividing each side of inequality by a positive number does not changes the inequality. If we have 8 greater than 4, if we divide with 2, 8 by 2 4, 4 by 2 2, true. Means the relation does not changes. If A is greater than B and M is greater than 0, means M is positive, then with same number we can divide on both sides. The inequality does not changes. Greater than will be same like greater than. If it is less than, and if M is greater than 0, which means M is positive, then the inequality becomes equal. But whereas if you multiply with if you divide with a negative number like multiplication, it reverses the inequality. If A is greater than B and M is less than 0, which means M is negative, then the relation will become reverse. Greater than will become less than. Less than will become and less than will become greater than, like that. Only while multiplying with the negative number or while dividing with a negative number, the inequality becomes reverse. In both the cases, inequality becomes reverse. And in one more case, if we take reciprocal of each side of inequality, suppose if A is not equal to 0, B is not equal to 0, and if A is greater than B, if we take reciprocal on each side, here left hand side A is there, its reciprocal is 1 by A, right hand side B is there, its reciprocal is 1 by B. Instead of the numbers, if we take their reciprocals, so instead of greater than, the relation will be less than. So here A will, if we take reciprocal, A and B will be in the denominator place. That's why A should not be equal to 0, B should not be equal to 0. Because anything divided by 0 does not exist. So if we take reciprocals of left hand side, right hand side of inequality, the inequality gets reversed. So in 3 cases, while taking a reciprocal, while dividing with a negative number, while multiplying with positive number, in these 3 cases, the inequality becoming reverse. In remaining all cases, it is same as it is. Okay, children, these are the properties of inequalities. These are the properties of inequalities. Next, children. Next, we have, children, types of inequations. Next, we have types of inequations. So, basically, there are 2 types of inequations. So, first type is absolute inequations. Second type is conditional inequations. In inequations, mainly we have 2 types. One is absolute, second one is conditional. So, absolute inequations. Absolute inequations means if you observe this inequation x square greater than 0, if you take this inequation and if you substitute some values of x in this inequation, like minus 1 whole square, 1 is greater than 0, true. If you keep minus 2 whole square is 4, greater than 0, true. If you take 5 whole square, greater than 0, 25 greater than 0, true. Like that, though we can take minus value or plus value or any value in the place of x. In the place of x, it will be always greater than 0. It will be always greater than 0. Here they have to give some condition, children. X can be positive integer, x can be negative integer. Because if you keep 0, 0 square equal to 0, which is not true. So they have to specify the replacement set, which values we have to take. Or they can keep greater than or equal to 0. So then we can take 0 also, it will be equal to 0, true. So like this, if the inequation is true for all values of x, then such inequation is called absolute inequation. Means the inequation which is true for all values will be called as absolute inequation. So inequation which is true for all values of variable is known as absolute inequation. So like x power 4 greater than 0, y power 6 greater than 0, a square greater than 0 means base quantities rise to the even exponents, even powers. Even powers are all considered as absolute equations. Absolute equations. Next, children, we have conditional inequations. Suppose if we have one inequation like x plus 5 greater than 6, if we keep minus 1 plus 5 greater than 6, 4 greater than 6, false. X equal to 1, 1 plus 5 greater than 6, 6 greater than 6, false. X equal to 2, 2 plus 5 greater than 6, 7 greater than 6, true. Means the inequation which we have taken, for some values of variable it is true, and for some values of variable it is not true. Means for values x less than 2, like minus 1, 1, it is not true. For values, if you keep 3 also, 3 plus 5, 8, 8 greater than 6, true. For values x greater than or equal to 2, for these values it is true. For x less than 2, these values it is false. So for some values it is true, for some values it is false. This type of inequations are called conditional inequations. Means they may be true for some values, they may not be true for some other values. They are called as conditional inequations. Means which is not true for all values of variables. Means which is not absolute. Is called conditional inequation. Next one, solve the inequations x plus 9 greater than 20 or 2x minus 9 less than 20. So x plus 9 greater than 20. So same number we can subtract on both sides, because we want to, in x plus 9 greater than 20, for finding x, we want to isolate x. So whatever extra value is there, that to be removed, plus 9 is there. So for removing plus 9, we can add minus 9 or we can subtract 9 on both sides. Adding minus 9 is same as subtracting 9, both sides. So x plus 9 minus 9, 20 minus 9, plus 9 minus 9 cancel, x greater than 20 minus 9 equals to 11. So x greater than 11. So for all values x greater than 11, this equation will be true. Means if we keep 12 plus 9 greater than 20, 12 plus 9, 21 greater than 20, true. Like that. If we keep 13, 22 greater than 20, like that. For all values x greater than 11, it will be true. For values x less than 11, it will be false. So it's an example of conditional inequation. Next one. 2x minus 10 less than 90. So 2x minus 10 less than 90. We want to isolate x term. Minus 10 is there, extra term to be removed. We can add its additive inverse. Minus 10 means we can add plus 10. So 2x minus 10 plus 10 less than 90 plus 10. Minus 10 plus 10 cancel. 2x less than 90 plus 10, 100. So still this 2 to be removed. So we can divide with 2 on both sides, because by dividing with positive number, inequality does not changes. So 2x by 2, 100 by 2, 2 to cancel, 100 by 2, 50. So x less than 50. So this equation is true for all values which are less than 50. All values of x which are less than 50. Let's take one number 40. 2 into, in the place of x, I'll take 40. Minus 10 less than 90. 2 into 40, 80 minus 10 less than 90. 80 minus 10, 70 less than 90, true. Next example. Solve the inequality. Solve the inequality. 5x minus 8 less than x plus 4 by 3. X plus 4 by 3. 5x minus 8 less than x plus 4 by 3. So we have to isolate x term. Here by 3 is there. Let's multiply with the into 3 on both sides. 3 into 5x minus 8. 3 into x plus 4 by 3. 3 gets cancelled. 3 into 5x, 15x. 3 into minus 8, 24. Less than x plus 4. Now x terms one side. X will go this side. Minus x. Minus 24 will come this side. Plus 24. Minus x plus 24. 15x minus x, 14x. 4 plus 24, 28. 14 comes in this side. X less than 28 by 14, which is equal to 2. X less than 2. So the given equation will be true for all values x less than 2. Means we can take 1, 0, -1, -2, any value, the equation will be true. So, okay children. So what we have learned, properties of inequalities. If A greater than B, B greater than C, then A will be greater than C always. Adding same number on both sides of inequality does not change this inequality. Subtracting same number, multiplying positive number. Only while multiplying with a negative number, inequality gets reversed. Dividing positive number, no change. Dividing with a negative number, inequality gets reversed. Taking reciprocal, inequality gets reversed. What are types of inequations? Absolute, conditional. Absolute means they will be true for all values of x, all values of variable x. Next, conditional means they will be true for some values, they will not be true for some other values. So, okay, children. So, let's learn the remaining topics in our next video, children. So, thank you for watching our video. So, please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.